Okay, so we got this number, and we've got to write it in scientific notation. And let's get my lighting there. So, scientific notation looks like this. You have a digit, and then the decimal point, and then the rest of the digits, and then times 10 to the power of something. So that's what it looks like. So the objective is to get the decimal point just to the right of the first non-zero digit, right? And then of course we only have one digit afterwards, which is an 8. So how many places do we need to move to get the decimal point over here? 1, 2, 3, 4, 5. So we need to move 5 places to get the decimal point over there. So writing this in scientific notation would be actually 4.8 times 10 to the power of, now it's either 5 or negative 5. Well, the negative exponents are what are giving us the smaller numbers, right? The positive exponents give us the bigger numbers, right? So it's 10 to the power of negative 5, right? Now, I'm just going to check that to show you all that, just to make sure that we can clearly see that this is the same thing as this, right? So the trick is 10 to the negative 5 is 1 over 10 to the power of 5, right?
5. Oh.
Yeah, that's what it means. That's exponents. So we had it. That's we went over that a few times. So that's our exponents there, right? Now 10 to the power of 5 is a 1 with 1, 2, 3, 4, 5 zeros after it, right? Right. So it's basically 100,000th. 100,000th is what it is. And as a decimal, it is 0. Well, the way I like to think of it is, okay, 1/10 is 0.1. That's 10 to the power of negative 1 is 1/10. 0.1 10 to the negative 2 is 100th. 0.01 and so on. And like 10 to the negative 3 is 1,000th. 0.001. Notice that there are, for a negative 3, there's 2 zeros and then a 1. So for a negative 5, there's going to be 4 zeros, 1, 2, 3, 4, and then a 1. So it's 0.00001. Now, if you guys have that, remember that exponents review worksheet that we went over? So that's something that you ought to be looking at and recalling. All right, so we've got this as a decimal. And again, just make sure you review. When we first covered scientific notation, we did a list of powers of 10, and we converted our negative powers of 10 to decimals. We had on it like a table like this, which is really helpful. But in any case, 10 to the power of negative 5 is 0.00001. And so 4.8 times that, right? Well, that's going to be obviously a small number, first of all, right? A big long decimal. And it will indeed, if you look at it, think about it. What do you think if you do this times this? What do you think you're going to get? Are you going to get what we began with?
Yes.
Right, because it's kind of like, see that 4 there is going to multiply by the 1, and so you'll get 0.0, and so you'll get 0.00004. So if it was 4 times that, this is what the decimal would be, right? But it's 4.8 times that, and so that 8 becomes a digit over on this place value here. Does that make sense?
Yeah.
Anyway, but this is just checking. I just want to show that this is equal to that, and we've just checked it, right? But if it's rule of thumb, like if you're dealing with a small number, you're going to have negative powers of 10. If you're dealing with big numbers, it's going to be positive powers of 10, right? So that's that one, right?